When you open Aspen Plus, this is the first outlook of the interface. Here you can see two options. Either you can open a local example from the drive, or you can create a new case. To open an existing case, you can press Ctrl O, or you can browse it from here. Either you can browse it from the pre-installed model examples, or you can open a new case that you are already working on. Alternately, you can create a new case by pressing Ctrl plus N. Here you have couple of pre-installed templates. With the pre-installed templates, you have different categories including chemicals, gas processing, mining and minerals, refinery, specialty chemicals and pharmaceuticals, or there is a general template for a random case. For all these templates, you have couple of options with the units, for example with the English units, or with the metric units, or with the metric units with the degree Celsius, bar and time in hours. Under each category, you can see couple of other options, and for these options you can notice the units from here, corresponding property method that is most appropriate for that category, also the flow basis, and also regarding the stream report compositions. These are the default settings. If you want, you can change these settings in the interface as well. To open any case, just select it, select the appropriate unit, and click the Open Selected Template. As you can see from the top, this is the menu bar where you have Home, New, Customize, and Resources. You can open the pre-installed model examples where you have options of multiple pre-solved examples starting from the batch to the bulk, examples regarding energy analysis, fertilizers, a special category for the pharmaceutical applications, for the polymer applications. You can open any of the pre-installed example from here. From the fertilizer sector, you have pre-solved examples regarding ammonia, ammonium phosphate, green ammonia, urea. For beginners, I strongly recommend to look into the pre-solved examples before they can start their own version. Regarding green ammonia, where the hydrogen source is the water electrolysis, you can select this example and open it from here. Another thing you should notice from here is the format of the file that is currently labeled as Aspen Plus compound file. We'll discuss different file formats later on. Just select it and browse it from here. Either you can close it or you can open in entirely a new window. This is how to open an existing file from the computer. At the very top left of the window, there is a quick access toolbar where commonly used icons are placed. You can customize the quick access toolbar as per your requirement. Then to the right, there is a file information where file name, its format, and Aspen Plus versions are mentioned. Below is the menu bar where menu options according to the working environment are provided. The extreme right tabs of the menu bar are commonly the contextual tabs. Then to the right there is a help button. We'll come back to this option later on. Below menu bar there are ribbon groups, and these ribbons correspond to the specific menu option. For example, in this window the ribbons correspond to the flowsheet modification. This is the navigation pane where we proceed from top to the bottom, and this navigation pane is available for all the working environments. The working environments are mentioned here. These are the 4 working environments including properties environment, currently active simulation environment, safety analysis environment, and energy analysis environment. At the bottom of the environment, there is an option to check the status of the current simulation file. These are the window tabs. The currently active window is open, whereas all other open windows are tabbed together. At the bottom right corner, there is a zoom control option. You can either slide the zoom controller to adjust the zoom, or you can click the zoom fit to fit the flowsheet to the entire window. Let's explore the Aspen Plus help in detail. In the content menu, there is a separate properties environment where you can get help for specifying components, specifying physical property methods, or parameters, or chemistry. There is a help for the estimation of the physical properties, regressing property data, NIST thermodata engine, and so on. There is a separate section for simulation environment where there is a help for defining the flowsheet, how to specify a stream, a comprehensive help regarding unit operation models available in the Aspen Plus, and separate section for simulation and analysis tool, and a very valuable section regarding Aspen Plus references. The above sections are mainly focused regarding defining and specifying the input, but this Aspen Plus reference section has a very valuable information regarding the backgrounds and the literature information to the relevant content. For example, you can open either property methods or you can open the property models. We'll have a very dedicated discussions on the methods and the models in the future videos. Just to get an overview what these property models look like, here you can open thermodynamic property models. You want to look what does equation of state means, and specifically how Peng-Robinson equation looks like. You can jump into the Peng-Robinson equation. Here is the Peng-Robinson equation, and these are the coefficients of the parameters those define the Peng-Robinson equation and differentiate from the other equations. At the very bottom of this page, you can also notice the literature references. Similarly, if you are interested in the activity models, for instance, in the NRTL model, this is the mathematical relationship for the NRTL model to determine the activity coefficient gamma I. Here are the parameters and the coefficients for the NRTL model equation. And at the very bottom of the page, you can also notice the literature reference for this equation. I will particularly emphasize on one of the section, that is troubleshooting. Aspen Plus has already provided the common errors that appear in the Aspen Plus while simulating a case, and also suggested some possible measures to solve the error. For instance, the common errors regarding flowsheet convergence are mentioned in this section. One of the very common error is the 0 feed to the block bypassed, or simply 0 feed to the block. Here couple of causes are mentioned. One of them is stream in recycle loop have zero flow initially. How to resolve this error if appears in the flowsheet simulation? They have suggested couple of options. Another possible scenario can be errors in unit operation models are bad specifications. Those can cause blocks to produce empty or zero flow outlet streams. What can be possible cause of this error and how potentially it can be resolved? This is also mentioned over here. So whenever you experience an error or warning in the simulation, I advise you to first have a look into the Aspen help. Most probably you will end up with the possible solution. Otherwise you can consult other resource material as well. At the very bottom you can also notice the glossary. Here they have provided some basic definitions of the terms involved in the simulation. You can also search your query from the search bar. For example, if a term appears like CPIG, what does it mean in the Aspen Plus? You can simply click over here. Aspen Help will determine all the areas where this term appears. Simply CPIG means ideal gas heat capacity. Depending upon the requirement what you are looking for, you can consult other sections of this help as well. If you want to save a simulation, you can simply click from here, or from the file menu you can save the existing file or you can save as a new case. There is a section of options to configure the user's preferences. Let's see what options are available for the configuration. Here you can notice configurations regarding the simulation. How would you like to run the simulation? If you are interested to animate the flowsheet while calculation, for economic evaluation you can define a default economic template. If you want to allow the simulation to run without complete specifications, you can also configure the property basis. What component data bank should appear as a default component? Which file formats should be included in the compound file? What is the default working directory? Similarly, you can tweak several other options for the global settings of this simulation file, or you can directly take the help to define the configurations of the file as well. So what file formats are available? To save any file, you have a couple of options for the file formats. For instance, the compound file, Aspen Plus document file, Aspen plus backup file, or you only want to save the template. What does it mean by all these different file formats? We can consult again the help. You can simply search file format from the search bar. So the first option is file formats in Aspen Plus. This is what we are looking for. In total, it has produced 117 results regarding file format. So what does it mean by backup file? .bkp, and the backup file is archive file containing simulation input and the results. Whereas the compound file, it is a consolidated file containing all files used by the simulation. The third option, document file, that appeared in the save as option. It's a quick restart file containing simulation input and results and immediate convergence information. So if you would like to save the consolidated information of the simulation, then you will preferably end up with the compound file. You can also couple of other file formats. You may not save them by your choice. Most of them are accompanied with the compound file. The fourth option is the template file format with the extension .apt, and this is the template containing default inputs. This is a very quick information regarding different file formats and the templates available in Aspen Plus. I would like you to explore other template files and compare them. For instance, the chemical with English unit has a property method of NRTL. This is mostly used if the components are of the nature of non-ideality, whereas the gas processing, where it is very common to use equation of state, and the most preferable equation of state is the Peng-Robinson equation of state. Besides, depending upon the norms of the industry, the unit set is also tuned over here. Or if you do not have any preference, you can open a general method. Either you can open the selected method from here, or without any preference you can open a new simulation from here. Also, I would like you to explore other pre-installed examples that might be of your interest. One of the examples that I will suggest at this moment is regarding carbon capture. Here is a case for CO2 capture from coal power plants using monoethyleneamine. Monoethyleneamine is commonly used solvent for industrial scale carbon dioxide capture. Let's open the file. I'm not interested anymore in the existing files that I was working on, so I can simply close it. Even those files were not of much use for me. I'm not interested in saving those files. To view better, you can collapse this dashboard. Also, you can collapse this model palette. If you would further like to extend, you can click this zoom to fit button. In one of the future video, we'll come back to the same example to explore it further.